At the end of the last video, I asked you to try problem 15 from the homework. So that's sketching y equals secant of negative x minus pi over 4 minus 2. I've gotten started here. Didn't get very far. The first thing we want to do is graph the corresponding transformation of cosine, since secant is the reciprocal of cosine. First thing I notice is that this is not in factored form and I've got a negative in front of that x. So I'm going to put it in factored form by factoring out that negative. That just changes the signs here. So I get cosine of the opposite of x plus pi over 4 minus 2. Cosine is even. Opposite input, same output. I get to ignore that negative sign. So this is cosine of x plus pi over 4 minus 2. And just like we discussed, if sine is odd, its reciprocal will be odd. Same thing with secant. Since cosine is even, secant will be even. Okay, excellent. So now what I'm plugging in is changing things horizontally. Everything else, which in this case is just the subtracting 2, is going to change things vertically. I'm just going to track that vertical change first. Doesn't matter which I choose to do first, either is fine. A regular cosine would have a high of 1, middle of 0, and a low of negative 1. I'm subtracting 2, that's going to move everything down 2. So 1 minus 2 is negative 1, 0 minus 2 is negative 2, negative 1 minus 2 is negative 3. These are going to be the y values that I care about. Okay. All right, for the horizontal stuff, I know that cosine does its thing once as the input, which in this case is x plus pi over 4, varies from 0 to 2 pi. Now I'm going to go ahead and go with 0 to 2 pi, even though I know I'm going to need to ultimately adjust. If you wanted to adjust ahead of time and say, let's go from negative pi over 2 to 3 pi over 2, you could certainly do that. But I'm so used to when I'm graphing cosines starting at a high point, unless I flipped, in which case I start at a low point, that if I adjust so that if I have to start at a middle point, I'm afraid I'm going to forget. So I'm going to just always work with the interval from 0 to 2 pi. I know it's not going to start me at a middle value, but I'll adjust. Okay, so I subtract pi over 4 from each piece. And we get negative pi over 4 less than or equal to x, less than or equal to 2 pi would have been 8 pi over 4, minus pi over 4 is 7 pi over 4. So if I look, my period is still 2 pi. That's because here the number I was multiplying by was 1, so we get the original period of 2 pi divided by 1. Or if I looked at this version, where I'm multiplying by negative 1, it would be 2 pi divided by the absolute value of negative 1, which still gives me 2 pi. I can double check. 7 pi over 4 minus negative pi over 4 is plus pi over 4, so that's 8 pi over 4. That's 2 pi. It checks. Excellent. So the increment is 2 pi divided by 4, which reduces to pi over 2. So the x values that I care about, let's see. I can record those here. The x values that I care about, I'm going to start at negative pi over 4, and I'm just adding pi over 2, which I conveniently know is 2 pi over 4. So adding 2 pi over 4, I'll get positive pi over 4, then 3 pi over 4, 5 pi over 4, and 7 pi over 4, which, yes, is my ending point. So these are the x values that I care about. So I will mark off. Here's negative pi over 4, pi over 4, 3 pi over 4. Make sure I'm saying each tick mark represents a distance of pi over 4. So these points are 2 tick marks, or 2 pi over 4 away from each other. Then there's 5 pi over 4 and 7 pi over 4. Okay. The y values that I care about are all negative. -1, -2, and -3. I like to draw in dotted lines at those heights. And here I had not done a flip, so this is going to follow the usual pattern for cosine, which is that it starts high, then middle, then low, then middle, then high. So I can draw in my cosine function like so as a dotted curve. You will notice this graph is never zero. Super important to remember that the asymptotes are not where this function is zero. The asymptotes are where cosine would be zero. And that's whenever we're at a middle value. So I can see I'm going to have an asymptote at pi over 4, and I'm going to have an asymptote at 5 pi over 4, but I don't have an asymptote at my starting point and my ending point, and I always want to start and end at an asymptote. So I either need to extend the graph to the left until I hit the next point where I would be at a middle value, and then draw in that asymptote, and then I could go from here to here, or I could extend this to the right until I hit the next place where we're at a middle value. I'm going to just extend to the left. So let's see, my increment was 2 pi over 4, so the next place would be -3 pi over 4, where we'd be at a middle value, and there I'd have an asymptote. So I'm actually not concerned with this portion of the graph because I can get one full period between these two asymptotes. So then I flip the bumps, making sure that the low point of the secant graph meets the high point of the cosine graph. And again, the reasoning there is not that the reciprocal of -1 is -1, but the reciprocal of -3 is not -3. So here, flipping the bumps doesn't correspond directly to taking the reciprocal of the y values that I have, but in doing the transformations, we did the same thing to the y values of cosine that we're doing to the y values of secant, and so it does turn out that this high value of cosine becomes this low value of secant. Pretty cool. And totally fine if your version started at pi over 4 and went to 9 pi over 4, which would be the next asymptote. But do make sure, I asked for just exactly one period, so do make sure that you've got just one that opens up and one that opens down.